Welcome, and thanks for joining us. Today, we're going to be talking about how Google Cloud Observability suite of products is creating a better developer experience for its customers. I'm Bryan Zimmerman, Product Manager with Google Cloud.
And I'm Meredith Hassett, Developer Advocate at Corvid by Wix.
As I mentioned, we're going to be talking about specific tools that help developers be more successful day to day. But these exist within a larger ecosystem. And this toolset is based off the same planet-scale core platform that powers Google's internal observability. So you know it's been battle tested. In addition, it comes with built-in zero-day observability for key Google services. This is all under the umbrella of our logging and monitoring products, but it includes much more. When talking about how to help developers day to day, we first have to ask, what do developers need from their observability toolset? When we talk to our customers, there are three key themes that we see. First, they need to diagnose issues quickly. When there's an issue with your application or site, there isn't time to go hunting for logs or hunting for metrics. You need to be able to find the problem and diagnose the problem with ease. Second, some problems are harder to find than others. And with the large data available about your application and the infrastructure it runs on, especially in the cloud, having a tool set that helps you effectively find needles in that haystack is really important. Thirdly, not all issues can be reproduced in a development environment. And even if they can be, it's time consuming, and sometimes you need answers quickly. So being able to debug in production is often critical to reducing mean time to resolution and being effective in the cloud. We're going to be talking about each of these areas with specific examples of how they can help developers be more effective. First of all, let's talk about diagnosing issues quickly. Metrics are a key part to understanding problems and what's happening with your system. Traces and logs have the context and details to help you diagnose the cause of said issues. But they're not always linked together. So going from a metric to the requests and logs that generated that particular metric data point is difficult and important to be able to diagnose issues quickly. What's the solution? A feature we call example traces, otherwise known as trace exemplars. In the screenshot on the left, you can see a heat map distribution of latency that has two important additions. One, there are aggregate percentile lines that help us understand how this distribution is trending. Second, there are example distributed traces that have been sampled. These represent complete requests, and you can actually drill into that request without leaving the context of your monitoring tool, which you'll see in a moment. Now let's see this in action. The demo we're about to show you is of our example application called Online Boutique. In this scenario, users of the application who normally experience great performance have started to notice extremely degraded latency. The developer in the video will show you how to use the Google Cloud Operations tool suite and example traces, as I mentioned earlier, to quickly diagnose said issue. Here we will show how we can use cloud monitoring and cloud trace to quickly understand where we should be focusing our attention with regards to a particular issue. In this case, we have an alert related to 99th percentile latency, which has spiked quite significantly recently. Drilling into our performance dashboard, we can see that there was a significant increase in latency around the time of the alert. This seems to possibly correlate with error rate, but not exactly. This increase can be shown both by the distribution itself, but also the aggregate percentile lines and how they have increased over time. Let's drill in further to the inflection point. Now, typically, this is actually quite difficult to go from here. Understanding the specific request that led to that metric data point is not always easily available. However, with Google Cloud Operations, we can overlay example traces onto this metrics graph. Now we can easily, without switching context, drill into exactly what was happening at the time the issue was observed. So in this instance, this is a call to the product service which is making a call to get product and making further calls to get product, which is an interesting behavior. Out of the 7 seconds duration, about 6.9 of them were related to get product. Let's see if this seems to correlate with other types of requests. This is another similar such product call, which has a similar profile of child calls to the product catalog service. This here is a cart operation, so that's different. However, when we look further, it has the same repeated get product call in the product catalog service that we saw earlier. And if we look further, we're going to see similar behavior of product catalog service operations representing the majority of the latency. Now, to be sure of this, let's compare with traces prior to the issue. Here's a similar get product call, and it's making calls to the recommendation service, again to the get product service, and it makes a few calls to get product, which is what we saw before. However, if you look at the total latency, only 31 milliseconds were spent within the get product service. This compares to 20 seconds in some of the other examples we were investigating. So it definitely seems to be a delta in the length of time of get product calls that is representative of this latency. At this point, I have a viable hypothesis for what caused this issue, and I got there without actually leaving my monitoring dashboard. From here, I would look at logging, perhaps debugging, error reporting, to try and understand what was actually causing this issue. But what we've shown here is that with these integrated tools, you can quickly understand where you should be focusing your attention and where the problem may be located.
The previous example focused on speed, but that's not always what you need. When it comes to finding needles in the haystack, it's about breadth, depth, and thoroughness of your tool set. In the next example, we're going to show how you can use the Google Cloud Operations tool suite to look for a very difficult to find cause of an issue. This focuses on logging and trace, and we'll follow that up with Profiler.
To demonstrate finding a needle in the haystack, we're going to look through Cloud Monitoring, Cloud Trace, and Cloud Logging. Starting with Cloud Monitoring, we see that we have an alert related to latency. Looking at our dashboards, in specific the performance dashboard, we see that there actually was a spike in the errors on the front end that occurred fairly recently. To troubleshoot this, we're going to drill into things with Cloud Logging. Looking in the logs viewer, I can very easily filter for the log lines that contain error. I can also drill down to the Kubernetes resource type where the errors came from. In this case, they're almost all from the front end. So what's happening in these instances? Drilling in to the details for these logs, I can see what's happening. In this case, I see failed to get recommendations. I expect that other errors are very similar. Failed to get product recommendations again. I can add this to the summary line in order to see how prevalent this error is within my filter criteria. Now, to understand what the recommendation service is doing, let's open Cloud Trace. And in this case, I'm going to filter for spans, otherwise known as service calls, where my front end is calling my recommendation service. We can see that the latency spiked heavily around the time that I received the alert and started receiving those errors. Let's see what's happening. What we can see here is after calling list recommendations, the system is making multiple calls to get product from the product catalog service. That's interesting. In fact, in this 19-second trace, which started as a get cart request, almost all of the latency is spent within those get product calls. That's definitely not what we want to see. And it suggests that that's where the issue is occurring. We're going to use cloud logging to understand what's happening within that product catalog service. Again, it's very easy to find this out by drilling in to the resource type in the Field Explorer. We're going to filter for the pod named Product Catalog Service. Now, what we can see is roughly at the time of the error, there is a massive spike in logs from this service. Narrowing down to this time interval, we can see that almost all of these logs are successfully parsed product catalog. At this point, it's safe to assume that this is where I should focus my attention. I'm going to open up my IDE and understand what's happening with the parsing of the product catalog to find out why is it actually successfully parsing the product catalog so often. This is a good example of how to use the operations toolset, including logging, trace, monitoring, and more, to quickly narrow down a hard-to-find problem.
Sometimes a problem can't be easily found in the logs or the traces. It has to do more with the functioning of your running code, or perhaps it's about cost optimization. This is where Profiler is extremely useful. Kellyanne is going to show you how you can use Profile to solve these needle in the haystack type problems.
Cloud Profiler can help developers understand how their services are spending compute and memory resources. We will explore how Profiler can be used to identify optimization opportunities and help you run your services more efficiently. Profiler supports 4 languages: Java, Go, Node.js, and Python. For this walkthrough, we will use the product catalog service and its CPU time profile type. The default view for Profiler is the flame graph view shown here. It helps developers understand which portions of their code are using the most resources. In this service, we can see that the stack with the function parse catalog is using the most CPU time, or about 72%. We can see the parse catalog is calling the JSON unmarshal function. So this has to be the first focus of our investigation. Now let's open the top functions table and sort the functions list by the self time. We can see that 8.3% of CPU time is spent in the function state in string, which is not evident from the default view shown in the flame graph. By clicking on this function name, we load the flame graph in the focus filter mode. This mode is useful to identify functions which are called from multiple locations in your code. It also helps us understand the various calling paths into this function. This is very useful for understanding the resource usage patterns of library functions, which may be called from different locations in your code. Removing the focus filter resets the flame graph to its default view. Now let's examine how we can use the weight filter to identify profiles within a selected percentage of peak consumption. For example, top 10% indicates that only profiles that were collected during the top 10% of CPU consumption are presented for analysis. We can also use the compare to function to compare profiles from 2 different weight groups. Here we are comparing profiles from the top 10% with all profiles. The frames that are shaded in orange have higher resource consumption when compared with all profiles. We can see that there is some increase in resource consumption in the client handshake function stack as well. Resetting the compare to loads the default flame graph view. So these are some of the features of Profiler that can be used by developers to understand how their services are spending resources and where they should start their optimization efforts.
Our final scenario talks about how to debug code when it counts. If you've ever had a scenario where you could not reproduce an issue in your development environment, then this is for you. If you've ever had a scenario where that one line of logging that you needed was not there when you needed it, this is for you. In this next demo, we're going to see how Cloud Debugger can help you debug in production when you need it most. To start this journey, we're going to open error reporting. Error reporting automatically surfaces errors found in the logs for easy discoverability. Within the error group, we can see the trend where this error has occurred, where in the code this error has occurred, and easily link to the logs that generated the error. Exploring these logs, we can see quite easily that this is exclusively caused by the currency service. We can inspect the logs for further details, including resource context. However, this doesn't actually show us what's happening and causing this particular problem. For that, we're going to open Cloud Debugger. Debugger allows us to see what is happening in our actual running production code. In the logs, you saw that the error was happening at line 55 of the currency service server.js. Clicking here, we can take a snapshot of what's happening at the code at that exact position, inspecting the details of the variables. This was done without restarting the service, without pausing the service, completely safe in production. Now the cause isn't obvious here, but we can see from the code that if results.units is not greater than 0, it would throw this error. So let's see what results.units is set at. In this case, it's set at not a number. So that's obviously not going to work. Let's see how this was actually set. And in this case, where we set that value was also not a valid number. As such, it would generate the error that you saw today in the logs. Next, we would need to update the code to resolve this issue. But you can see how with production debugging, this was easy to find without any impact to my system. And that concludes our 3 scenarios. Next, we're going to hear from Meredith Hassett from Wix.
Thanks, Bryan. At Corvid by Wix, we're all about developer velocity, and using tools like Google Cloud Operations really helps developers speed up their process. Corvid enables a JavaScript web development environment on top of Wix sites, which enables developers to add additional console logging as well as error handling that's crucial for their logging experience. By integrating Google Cloud Operations into Corvid, developers are able to rapidly debug issues that come up in production and make sure their users are getting the best experience. Let's take a look at how a real-life Corvid developer uses Corvid and Google Cloud Operations to build and debug issues on their site.
Let's take a look at a vacation booking site where users can provide their preferred check-in and check-out dates to get updated quote information about their requested holiday. We're able to do this using Corvid and Wix to get dynamic information from third parties displayed on our screen. Let's take a look at how this looks in the code. In our Wix editor, we now see a new site structure and code IDE pane that becomes available once we enable Corvid. Corvid is our web development platform for Wix sites that opens up APIs as well as UI functionality for you as a developer. When we find the request quote function, we can see it's actually coming from the backend and the Logify file. So if we go ahead and take a look at our Logify file in our backend, we're able to find the request quote function and see that it's calling an API to return booking information about a property based off the user's inputs. Once that quote's returned, we may actually want to do some error handling to determine if there's any issues with the quote. So let's go ahead and log quote information and then check to see if the quote has any error codes. If there is an error code, we may want to return an error status to be able to better debug. We're able to pass through properties from the quote as well to the error. Once our error handling and logging is in place, if we publish, this will make our site changes productive. With our production site up and ready to go, let's go ahead and enable the logging. Back on our Wix site dashboard, when we go to Settings, Production Tools, Site Monitoring, we're able to easily connect to the Google Cloud Operations logging tools. When we connect, we just connect with our Google single sign-on account and we're able to get to the dashboard. Once we're in the Google Cloud dashboard, we're able to look at the logs for our site. So let's take a look at what a user's flow might look like and how we can do some error handling. Back in my Wix editor, I'm going to go to View Site, and on my site, I'm going to go through a user flow of trying to book a vacation. Let's take a look at the properties that are available and select one that looks like a nice vacation home. Once I'm on the vacation properties page, I'm able to play around with the quote information and see how changing my requested dates will change my quote information. We can go through trying to book this site as well. I now will try to place my booking. As a user, if I run into any issues, I can pass this information back along to the agency and see if they can help me figure out what's going on. As a developer, to make sure that your site is healthy, if we take a look back at our logs, we're able to retrieve if there is any information and find any errors. I can filter down for my errors, see that there was an issue with a quote retrieval, and determine what went wrong by taking a look at the information and the other events logged around it. Having integrated tools like Google Cloud Operations for logging of websites like those built on Corvid by Wix enables us as developers to do our jobs more efficiently, spend less time looking for errors, and be able to resolve any issues that our users may be having when they're coming to our sites.
Thanks, Meredith. And there you have it. We've demonstrated how Google Cloud Operations suite of products can help make developers more effective and efficient day to day. Feel free to reach out for more information, or as always, visit us at cloud.google.com.